Since we want to be able to both write to age and get the age, then we say it's read write, and similarly for name. Okay, so then these are the same. Back in student.m, we see the same. But looking at main.m, the fact that these are now properties allows us to say alice.age equals 20 and alice.name equals @Alice. So what a property does for us is says that since we said there is a property called age, then alice.age is, by the conventions that are now going to be like something you should absolutely follow, alice.age is underneath the hood going to be translated to Alice set age 20. And this is going to be Alice set name @Alice. So this is what properties have done for us. It's allowed us to access and set instance variables using dot notation, instead of having to go through this set name and set age method or message passing. It's somewhat important, and yet at the same time not really that important, to remember that we are going through the overhead of a message pass. So it's not like in regular C, this is not a struct. So you would not be able to use dot notation on a pointer to a struct. This is an object. This dot notation is calling a method, and so there's some overhead to that. But again, it's Objective-C. Let the compiler handle any optimizations. Don't really worry about the overhead of message passings. Then down here at greet, we see s.name and s.age, which are equivalent to just sname and sage. And so this is why I said before you should follow the convention that like the getter is just called name and not get name, because s.name is going to expect the getter to be called name. And if it's not, you're not going to be able to use the property as expected.
So you still need the set name, age, those functions?
Wait till the next example. Yeah.
I'm not quite getting this, because you're saying that init is essential, or isn't it? Because the examples on the zip files don't have it.
I changed that. They should always have it.
They should always.
Yeah.
But it'll work without it?
So the reason for this is that NSObject's init method, so init is inherited from NSObject. And we see that student is directly inheriting from NSObject. And so because the init method of NSObject does nothing, then there is no difference between student alloc and student alloc init. Those two things are going to be the same. But you should always handle initialize object. I doubt NSObject would do this, but if someday NSObject changes its initialize method to now keep track of something, then this code will break because you did not initialize that object. Or alternatively, if inside of student, I decide to overwrite the init method and have it do something, define my own init method. We'll actually see examples of that later. But if I were to define my own init method, then all of a sudden everything in main.m would stop working because I did not initialize those students. So always even if you know you're inheriting from NSObject, still initialize it. Even if it's because someone later on coming around reading your code is going to be like, wait, this isn't initialized. Now they have to go check to make sure that the initialization isn't actually going to do anything. It's always initialize. Is there one last? OK. Any other questions? OK. Then come here. OK. So synthesize. This is what in the past was used to do exactly what you just said about getting rid of the getters and setters. So let's look at student 4. So we have gotten rid of the explicit declarations of the setters and getters from here, just deleted them. They were redundant to begin with. And in student.m, we have now gotten rid of the implementations of those things. In the past, you used to need to do like an @synthesize age equals underscore age messiness. The reason for that is because the compiler didn't used to be smart enough to recognize that if there's a property in here, then it should automatically be in here. Now it is smart enough. So now the property is enough to say that we want an instance variable called, well, actually, using the defaults, and this is again why we come back to underscore, the defaults of this line is we want an instance variable called underscore age that has a setter called setAge and a getter called age. And that setter and getter is going to be implemented using these particular semantics, but you don't have to worry about assign and non-atomic yet. This also means that before, even though we had said assign and non-atomic and read write, you are allowed to overwrite those. And so before, in the previous example, when we had explicitly defined setAge was not necessarily following these semantics. It happened to be because that's how we implemented it. We didn't implement it caring about whether it was multi-threaded and all that stuff. So you are allowed to override these behaviors. I actually think student 5 might go into that. So student 5, looking at student.h. Again, we still have age and name. Now in student.m, we still do not synthesize, but we just happen to decide to overwrite the setName method. This was David's example of if the name happens to be David, then change it to dummy. Otherwise, do the original behavior. So here we have overwritten what the default setting would do if we just did copy non-atomic. But if we also decide that we wanted to we decided that we wanted to override the getter and say return name. Now, because of the way things are, we do need to explicitly synthesize. So now we would need to say synthesize name equals name. And those should go away. It's only if you happen to be overwriting both the getter and the setter that we need to synthesize the variable again. Otherwise, it wouldn't know that this underscore name variable exists. This behavior is because of some backwards compatibility issues, but it's the way it is.
But if you use property, then the getters and setters are defined for you, or you have to define it?
Well, that's if you use property and you say rewrite. If it is a read-write property, the getters and setters are automatically defined for you unless you decide to override them. And if you override them both, then you need to synthesize again, because otherwise it doesn't know about that instance variable. Because like looking at student.h, we see property age and property name. We don't see anything about underscore age and underscore name, and that's part of the reason why we need to synthesize. It's messy, but rarely are you going to be overwriting both the getter and the setter anyway. You might be overwriting them if you are like trying to debug something and you add an NSLog to both the getter and the setter, in which case, remember that now you're going to need to synthesize or else it'll yell at you. Questions?
So you mean like if we change only sender or getter, we don't need to?
Yeah. See, if I get rid of this line, now I'm going to get a bunch of errors. If I now get rid of this setter, I don't have any errors anymore. because as long as I only override one of them, it's fine. It's also important just to recognize synthesize because you're going to see it in a lot of prior examples. Like a lot of online things you find will use synthesize.